Hi, my name is Kenny, and today I'm going to be talking about solving systems of equations using primarily three methods. Um, so, oops. So first, let's talk about what a system of equation is. Basically, it's two or more linear equations, i.e. equations that can be graphed as a line, as these two are, that have variables with the same meaning at least once. So if we look at just this line, y equals x plus 3, um, we can see that every single x value has a corresponding y value, as is the nature of a line, and every single pair of x and y values, otherwise known as points, is equally acceptable as a solution to this line, because that's what a line is, all of the possible solutions to an equation, this equation. And the same is true for the other line. Every pair of x and y values is an acceptable solution. Now, in solving a system of equations, we're trying to find a solution to this equation over here that is the same as the solution to this equation, and we can see that in an intersection point. So the first method we're going to be using for solving a system of equations is graphing, because that's what we've been talking about. So in this method, we'll usually get a system of equations like this, and then graph them, obviously. And if the equations are in y equals mx plus b form, like over here, where m and b are numbers, and which looks like this in use, then we can graph them pretty easily. So I'd say the first thing that we should do is graph the y-intercept, which is this b value over here, which is this 3. And we know that that's going to be a point on this y line over here. So let's do that first. And then from there, we can look at our value of our m, which is our slope. And it's helpful to always think of this as a fraction. So let's turn that into a fraction. And so all we need to do is count the boxes. So because this is -2 over 1, we're going to go down 2 and over 1. So that's where we're going to graph our other point, and that's what the line is going to go through. Now, if this was a +2, for instance, we would go up 2 and over 1 to the right. And if it was like -1/2, then we would go down 1, because the 1 is on top, and over 2, because the 2's on bottom. So from here, we can check our work by plugging in one of the x values that we see on this line, let's say -1, and seeing if we get the corresponding y value. So in this case, that would be 5. And if you did that, which I encourage you to do so, then you would get that y equals 5. So we know that we did it right. So now let's do that with two equations. Feel free to pause the video here to try graphing on your own. And so like last time, I would encourage you to do the y-intercepts first. For this one, it's -2. For this one, it's +7. And then going for the slopes, for this one, it's up 4 over 1. And for this one, it's down 1 over 2. And then we can put in the lines and look for an intersection point, and we know that's our solution to this system of equations. So the other thing is, though, that sometimes we get weird answers like this. So if our lines don't touch anywhere, are parallel, meaning they have the same slopes, then there is no solution. And if the lines are actually intersecting at all the points, then we know it's the same line. Even if the equations look different, it can be the same line. So the next method we're going to use is the substitution method. So let's look at these two equations. Now we could graph them, but that may be kind of difficult. So instead, we're going to move one of the equations around a little bit. I suggest this one, so that we can plug whatever we get for the y value into this equation. It sounds kind of confusing, but it makes sense while we're doing it. And I would encourage you to try on your own. So let's look at this problem. We're going to move this -2, or this 2x over to this side so that our equation looks like this. And then we're going to pull that and plug it into this equation right here. That was one of the ones from the beginning. And so that's what the big equation looks like. And then we're going to just distribute our 4 so that this equals 20, this is negative 8x, and then combine everything, and then get our answer, x equals 2. Now we're going to take this x equals 2 and plug that into one of these equations right there. We can do either one. I just chose this one. So from there, we can find what our y value is. And so now we have our x and our y values, and we can, and since that's our solution, we'll just write that in an ordered pair. So this is what like our points look like. X always goes in front, then y. And because we know we can graph these, that's why we write them in an ordered pair like this. So our last method is the elimination method, which is not my favorite, but if you like it, you can use it. So in this method, we need our equations to be in both in this format, this something x plus something y equals a number. So for instance, if this was x equals 6 minus 2y, which is the exact same thing as this, then we would move it back into this form. So from here, we're going to try to get rid of one of our variables. I chose to get rid of the x's. So what you do is you multiply one of the equations on both sides by a constant. I chose 3 because the goal is to get rid of this, just all of this. So then we combine it. And we know that if we multiply both sides of this equation by 3, it'll be the same because both sides of the equation is equal. So from there, we can do our algebra, and these two cancel out, which is the goal. And then we end up with 7y equals 14. And we can find our y. And just like last time, we're going to pull that y into one of these equations, doesn't matter which one, to find our x. And so we do that, and we find our x is 1. And so we take our x and our y, and we're going to plug it in back into an ordered pair, and that's our solution. So lastly, like in the graphing solution, we can get possibilities where we end up with something like this. So the variable is gone, and we just have two things that aren't equal. And that actually means that the slopes are the same, and it's going to be parallel lines. And so we know that if there's no answer for this system of equations, and then if we get an answer that looks like this, then we're going to know that it's infinite possibilities and that it's actually the same line. All right, so you can pause the video here and try these on your own. And now I'll pull up the answers. And thank you.